231. January 2nd, I just ate. I watched 2 highlights in tennis. I'm ready to solve some LeetCode problems. And after that, I'm gonna train. But it'll be easy training. Still kind of a deload mode. Oh my god, another solved problem? I was hoping we can get something new. I mean, we did get something new on this, but I didn't know how to solve it. I think I need to check the hint. I said I'm gonna think about it, but I actually didn't. Maybe I should think harder. You know. So it's almost like a problem of overlap, right? We can think of those as start and end, and we can only count it if it's overlapping. I don't know if that makes any sense. Overlapping. I don't know, because we sort by the start, and then yeah, I'm not sure. Really not sure about that. Well, we'll take a look at the hint. Okay, I'll take a look at the hint. Let's get this one. Number of ways to split array. Zero indexed array contain a valid split at index I if the following are true. The sum of the first I plus 1 element is greater than or equal to the sum of the last. Maybe just the remainder, right? Remainder. There is at least one element to the right of I to the number of valid splits. So basically, we are going to do only split once, right? My goodness, this is I think that's also a very easy question. We just do a prefix sum, and that's pretty much it. Because there's only one split, right? One split, so we do prefix sum. Actually, I think this one will be easier, the second one. So we have 2, 3, 1, 0, right? So we do prefix sum, which is 2, 5, 6, and 6. And then we starting from this. And we need to calculate this, the sum of the remaining. And then remaining is 4, doesn't work. We're putting here, the sum of remaining is 1. Oh. Wait, hold a second. Wait, what? It doesn't work. Hold on, the sum of, okay, putting here, it works. Because the previous is 6 and this is 6. What's the other one? Split index has index 1. Oh, my bad. Is greater or equal to? Okay, I was just thinking about is equal to. Ignore me. Ignore me completely because I was being a dum-dum. Dum-dum. Alright, let's do this. Easy peasy, lemon squeeze. Yeah, I think I have to do a prefix sum. I don't think it's possible to avoid doing it. You know what? I think it is. I don't need to do a prefix sum. Haha. I get the sum of them all. Yeah, I just don't want to do a prefix sum. How about that? Right, I got a total sum. I got the rest is 0 and 4. I equal to 0. I mean, actually I equals to I smaller than nums dot size minus 1 I plus plus, and for each I need also a pre-sum. Okay, we'll do a pre-sum. So say pre-sum, well, plus equal to I, no, not I, nums I, and if pre-sum is larger or equal to sum minus pre-sum, All right, that's basically what it is. All right, if that's true, then res plus plus. And now we keep going and now we return res. All right, I'm going very fast. Very, very fast. We're doing the lightning fast. We check the two existing, looks good. So we're gonna say this is LeetCode what? 2270 prefix sum to compare with the remaining sum. You want to try another test case? Yes, I do. That I think is a good test case. Okay, let's try it. Submit it. See, that's why I hate it. Okay? That's why I hated it. Because I did not expect things like that. Alright, so in this case, pre-sum should also be a... that's okay. We're going to do long. And that's okay. We'll do long. Okay, so will it still work? I think it should still work. Everybody's long now. Unless long does also not work. If long doesn't work, it could be long. There we go. So the previous submission must be, yeah, it's Python 2022. It doesn't really require any thinking because, you know, it's Python. 2 milliseconds, 64.07 percentile. 2 milliseconds, 64.07 percentile. I'm pretty sure this is the optimal solution. Check editorial, prefix sum, blah blah blah, optimize prefix sum and suffix sum. Let's see how they optimize it. You get all the sum, you get the left sum, you get the right sum, you do the comparison. Exactly. Actually, you don't even need to do this. You can just do whatever I did, right? Okay, so that's it for today's challenge. So we need to figure out this. All right, so yesterday the idea is to find all the pairs, right? That's what I did. I found all the pairs. So I have basically a list of, you know, I0, J0, I1, J. Don't use I and J. Yeah, you can use I and J. J1 and I2, J2, right? So we have a list of this whose product are not the same. Now what we want to know is if I set one of them as P and R, how many Q and how many Q and S can we find? And I'm having trouble because I don't know how to avoid doing this part. So I can use binary search to get the left and right on the Q, which means we have all the J's in there. But we need to find how many J's are larger or equal to this J. That's great. Right? I need to find how many J's is larger than the one that I'm currently looking at. And how do I do that? I need to sort them again if I want a binary search. That's definitely not going to happen. And for each one of these, I have to do it again. We might need to find some other solutions. Let's check the hint. Okay, the first hint. Count pairs where this equals this using GCD to handle ratios. Oh man, I'm so close. Okay, so P times R equal to Q times S. And I am finding pairs of this and try to find this, I'm having problems. So change the problem from P divided by Q equals S divided by R. Now when I do that, I get the same, exactly same thing, but I don't have the problem of finding something that need to be in between those two. Now I just have P and Q, right? I just have P and Q. I can also use this to make sure that the two I find must have one in between. And then the problem becomes binary search. It's still the binary search, which is use the Q as the target, and we need to find who is larger than Q plus 1. Oh my goodness, this is... See, this is the thing. I was so close. I was so close. I just need to change my mindset like teeny tiny little bit. All right, teeny tiny little bit. I'm very disappointed. Absolutely disappointed. Nah, this one TLE as well. TLE as well. So we are going for solution number 3. What you doing, man? All right, so solution 3. Yeah, this is from the hint. Okay. So this is from the hint. Instead of finding P times R equal to Q times S, I saw him. We find P divided by R, right? P divided by Q equal to S divided by R, right? And then it will be much easier. We put all the, PQ and SR pairs, right, in all the matching, right? All the matching pairs in the same, all right, and then use binary search to create subsequences. It is a much better approach compared to solution 2 because the binary search only needs to consider S larger or equal to Q plus 1. Right, that's it. And we are sorted. All potential S are sorted already. Oh, dude, this is very disappointing. We're almost there. All right, so instead of products, we need to say ratios, right? And the ratios, I do need to find their GCD. I think we have GCD in math, right? So basically, the ratio is the same. That means they divide their GCD should be the same, right? So we can say P and Q. Now this is not minus 4. I think it's just minus. It's minus 1, minus 2, minus 3, minus 2 actually, right? Minus 2 because what we want to have is this pair. So if this is the last one, this is the last one, P can be here, Q can be here. Okay, Jimbo. So this is n minus 1, n minus 2, n minus 3. So n minus 2 is where we can get. And this is going to be P plus 1. Right, P, I have to skip 1, P plus 1 all the way to n. Now this is different. So we need to say G equal to mass.gcd P and Q. And I need to use I think a tuple works, right? So I say ratios, a tuple, P divided by G, Q divided by G, dot append P and Q. We're just gonna do tuple for all of them, right? So we do that. So this is gonna be ratios, and for all the pairs in this, and then for each pair, right? And then what we need to find, I have P and Q, right? So I just need to find the remainder, which I can do by, actually I don't even need a P, right? Q is the only thing I need. And I need to find bisect. Bisect what? I need to find something that's Q plus 1, right? Wrong. It's not P plus 1, this is P plus 2. Because plus 1 plus 2. So I need to find Q plus 2. So I need everything that's larger or equal to P plus 2. So I need to say R index shall equal to bisect. I believe it should be left. Bisect left pairs. Target is Q plus 2. Key lambda. Pair 0. And rest plus equal to, you know how many pairs there are. Well, the number of pairs is, I have the index, so it's going to be len pairs. Okay, len pairs minus r index, and now we return this. And the runtime will be O(n) squared. Call it log n. Not 100% sure, but all right. Let's run this first. Let's run it. Okay, we are no longer timing out. What we have is another issue. What the hell? We are so much smaller. Huh. Do we get the other one? How do I use the original test case? Oh, we reset test case. Let's just check if the original test case passes. Unknown network error. Please try again. What? Oh, lordy. It doesn't work. I guess never mind. Let's just let's debug. Okay. +1 +2. I say GCDP and wait, hold a second. I think S and R has issue. So you do P and Q and S and R, so you actually get an S. Right? You get an S. I think this should be 1. Because we're comparing the S. Yeah, we're comparing the S. It's absolutely bonkers. Because it's not sorted based on the second one. I see. We need to sort it first. Fairly simple. We can reverse the order, then the queue will be sorted, right? The queue will be sorted. I think I know why. So instead of going P first, we can go Q first. So Q will be 0, 1, 2. So you start from 2, end with n, right? And this will start from Q minus 2, minus 1, minus 2. And where will you end? You will end No, that's wrong. You will start from 0 and at q minus 1, right? And then we do this, then we do this. Oh my lord, there are a lot of things wrong here. A lot of things wrong. It's not p and q. You gotta be kidding me, man. You gotta be kidding me. They are indices. Dude, they are indices. What are you doing? Seriously, what are you doing? They're indices. So you need to do that. And then do nums p. I mean, here actually it doesn't really matter, nums p or nums q. Nums q. And then we'll append q and p, right? We'll append q and p. So now it's going to be q and this. And it's guaranteed that q is sorted, which means the r is sorted, right? So because I reversed them, so r is at the front, and r should be at the front because it's pqrs, right? pqrs, but r needs to be compared to q, right? R is compared to q, but q is at the front, right? Because it's hold on. Hold on. Okay, so this should be matching R and S, right? It's matching R and S. But when we do this, it's everybody is a Q and P, so they are reversed. So S is at the front, right? S is the front. So S is the front, Q is at the front. I get a Q out, but here I still need to do 1. Right? I still need to do 1. Okay, so we fixed that. Let's try again. On the easy cases, P is not defined because I forgot this is P. That was a silly mistake. Okay, this I don't understand. I fixed all the bugs and it's still not correct. I got PQ and I have nothing. I literally got nothing. Oh, of course, because you're checking on 1. That is not right. So when I reverse it, hold on. So I'm collecting Q and P, right? I collecting Q and P. So I collecting Q and P. So I actually collecting R and S, which means the R is actually 0. I don't know why I said 1. I think this should be 0. Okay, still not right. I think it's time to run the debugger. Things are not as how I want it to be. Okay, so when I put it in, I put in Q and P, right? I put in Q and P, which means in here, I will get R and S, right? I'll get R and S. And it's sorted, right? It's sorted. And we have to, and it's guaranteed that because P is smaller than Q, which means wait, hold a second. I'm got confused. So I get PQ and I have S and R, right? So I have all the PQ and SR, but it's sorted based on S. That's why I can now run binary search on the R. So I say, you know what, let's swap it. I'm gonna go Q and P, Right, I put Q and P. So essentially I put R and S in it as well, right? And when I do Q and P, it's guaranteed that Q is bigger than P. So R is bigger than S. See, that is where we have the problem. That is where we have the problem. That is exactly where we have the problem. Because in this case, I go P and Q, and then I have S and R as well. And if I run it regularly, P is, because I do Q is larger than P, then R will be larger than S, and that's not what we want. Okay? That's not what we want. So what do I do? So basically what we have is P over Q is equal to S over R, right? And the P is smaller, Q is bigger, so S is smaller, R is bigger. That's wrong. We need the other way around, right? We need this to be bigger and this to be smaller. How do we do this? How do we get this one bigger, this one smaller? Well, one way to do it is, instead of doing this way, I just do all P and Q, right? I just do all of them. Just ignore the ones where the difference between the two is not good enough. All right, so here is another idea. I will... All right, so I'm gonna undo a lot of stuff. You know what? It's stupid to undo. Let's just redo stuff. Okay, so here's the idea. I'll say P, okay, in range to n. Here Q in range to n. Okay, and if ABS P minus Q, because Q can be smaller, right? Q can be smaller. So if the ABS is larger or equal to 2, then I can try, say, well, this is interesting because P has to be smaller than Q for this to work. And no, it doesn't matter. So P is smaller than Q is fine, we get a pair. And then we have another pair when Q is larger than P. When P is larger than Q. So like this, and then we'll be here, right? It's okay. It's okay. It doesn't really matter. So we basically grab them all, right? We grab them all. So we'll have duplicates. Like the two will just swap. The two will just swap. The two will just swap. Yeah, you should just swap them. But it's the same runtime. So let's just go through them. Yeah, we just go through them and wait, hold on. Not really. Let me think again. So P and Q, okay, and we're letting everybody know. Sorry. Right? Think about it again. So we have P and Q.
Or something, it's like toilet paper still there.
Huh. That is very interesting. I'll flush again.
Should I pee then?
I'm gonna pee and flush. I think I know.
What?
I think I know how to solve this problem. But let me solve the other problem first. There's so much air.
What would you do?
I just flushed it.
And what's the problem?
I don't know the problem. I just know how to solve this problem. So we have to get two.
So I can pee?
It can pee. Well, I have to get two ratios. One ratio is the first is smaller than the second. First is smaller than the second, and the other one is the first is larger than the second. So we have to get both, and then from one of them, I need to hold on. Yeah, so we need to get the first one is PQ. Okay, we get a PQ, all possible PQs, and then we get all possible RS. But when we get all possible RS, we need to go. Yes, we had RS, but it has to be S divided by R. So we get both, right? And then for each PQ, we search the RS. So yeah, it's different. So basically, we say ratios PQ, and then we all copy the same thing, and this will be ratios RS, right? And we all do I and J. I minus 1, right? N minus 1, N minus 1, so it's N minus 2, right? N minus 1, N minus 2. So yeah, this and J in range I plus 2 to the n, because it has to be plus 1 plus 2, right? Okay, so we're gonna do this. GPQ is going to be I, J, okay? And ratios PQ is I divided by GPQ and J divided by GPQ, okay? And with an append I and J. So that is PQ. We also have RS, right? RS is the opposite, right? RS is the opposite. We need to do this, okay? And the ratios RS is going to be nums J, okay, divided by GRS, nums I divided by GRS, to represent S divided by I, right? However, when I append, I need to append I and J as well, because this is RS, right? This is RS. So we do that. Match is not found because it's not match, it's math, right? So we do that and we do that, and we need to have ratio pairs in items. So pq.items, okay. And then for each one, we get P and Q in the pair. And our index is going to be not pairs, but ratios, RS ratio. And we find Q plus 2. And this is also going to be ratios, RS ratio, right? 0. Incompatible. What do you mean incompatible? Incompatible return value. Huh? I see. Pairs. RS pairs. Tuples, tups. Yep, that should be tups 0. Right? And then we do this. And then we should be ratios, RS ratio minus R index. Alright? Yes. Alright, if this one still doesn't work, then I'm gonna just not keep banging my head on the wall. I think I don't have to keep banging my head on the wall, because this one most likely will work. No, I think I have this one already. This is the one. Okay, use this and let's run again. You better work. It does not work. Oh. How? How does it not work? Yeah, this is I'm a little bit confused. I thought we got everything. We are missing 137 pairs. I got the ratio and the pairs in PQ, right? So everybody in it has a potential to be PQ. And then I have oh, I know this is the problem. You don't have to do -1 because it's a separate system. There we go. There we go. All right, submit. And we are going to claim victory. We will conquer the world. Oh my goodness, what did I do? Yes, we conquer. Oh my god. 9,000 milliseconds. You are kidding me. You are absolutely kidding me. 5%. 5 percentile. This is so bad. This is so bad. Why? All right. Well, we'll leave the y for tomorrow. I mean, there's definitely a y here. I do believe this is a solution, but maybe I don't need to create a separate one. That's one thought. I don't know. I mean, yeah, maybe yeah. Like, why do you? Because we're append the same thing. We can append them in the same. We can append them in the same ratio, right? I think we can. We definitely can append in the same. So, avoiding creating another default dict, that might be. I don't know. Okay, let's optimize immediately here by. It's not even feeding time yet. Why are they so eager? No, it's only 8:49.
10 minutes.
Yeah. Okay, let's try a low-hanging fruit optimization. So I think I can remove this. Okay, a few things. We can do that, and that's okay. I probably can also simplify this. Anyway, we have this. We have this. So basically, I'll append them to the same thing, ratios, right? So I have this. We have this, ratios. Okay, so append them to the same system. Okay, the same system. And then here, I don't need a ratio. I just need the pairs. Values. Then for everything, that's actually not. I think this I can do -1 here. We do that, and this is just going to be pairs. Right, pairs, and this is the same. And here is going to be len pairs minus this. Because everybody will be bigger because the front is sorted. Okay, let's see if this one can magically make it faster. Well, it's very likely that this one will not, but we'll give it a shot. Yeah, this doesn't seem to be right. Huh. I wonder why. I seriously wonder why this one will not work. Because you're using, yeah, that's right. Because you're using this as PQ, right? You're using this as PQ. Ah, dang it. This doesn't work. This does not work. So, how do we optimize? I mean, this is not gonna, it's not gonna fly. Come on. This is terrible. 9,000 millisecond. Which part make it slow? Well, if you think about this, the J is getting bigger. So I put binary search. It's 1000. So basically what I want to know, because this one is also sorted by the front, so if I can reduce the binary search, so all I need to know is how many is larger than a certain value, right? How many is larger than a certain value? I don't know. I mean, why is it so slow? Oh, anyway, let's check the solution and then it's Lee hash map. Okay, I'll take a look at this and see if there's any way to make it faster. So okay, there are two things I'm thinking about. First is maybe there's a better way instead of doing binary search. Maybe there's a better way here, and second is there may be a better way to form the key. Now I'm using a tuple. Maybe there are faster ways to do this. For example, we can use an imaginative number, right? I think imaginative number will work here, probably make it faster. And of course, here, instead of putting ing, oh yeah, definitely, right? Definitely. So instead of doing an array of array, we can simply just use one of them. Oh, holy crap, I think you're right. Why do I use both to do this job? So this is optimized, hopefully. Right. Optimized version of solution 3. And I'm hoping this one will give me a fast. So everything is the same. And I'm not sure if it's going to be faster here, but I am sure it's going to be faster here. So I'll just do J. Okay? And here I'll just do I, which represent Q, is represent P, right? I need a ratio, and it's not really pairs, it's gonna be Q's, right? So for this, in range Q's, why do you do that? Why do I do that? So I can just say for Q in Q's, don't need this, R will be, this is no, this is needed, Q plus 2. I don't even need a lambda, just go directly here. Alright, land this minus this. Okay. Now we can see if this will make it faster. Simply because we're not using an array of tuples. Look at that, 87 milliseconds. Earlier I remember 233. Okay, 233. So we submitted this solution and we'll see our performance improve dramatically, right? We go from 9,000 milliseconds down to 4,000 milliseconds. Just that one change. So 40, 14, 17.51. Right, 17.51 percentile. So with that change, we shave off half of the time. Okay, half the time. Now the next one, maybe we do something with this ratio thing. Okay, instead of creating a tuple, which I think will take time. I mean, what else can I think about? We can use maybe a string would be easier. Yeah, let's say we do a string, right? Instead of this, we do a f string. Okay, so basically we just do this. We do a comma, right? And we do the remaining is here and that, right? We do a f string for this, and we do a f string for this, which is very likely, right? It's very likely that this is faster compared to using a tuple. Because tuple is an object. Well, technically I think string is an object as well. But I have a feeling that string is faster. So this is our solution 5. Try to be even faster, right? We try to optimize even more. Let's try optimizing it even more. And the way we're optimizing it is changing how we do the key. Nope. I don't think this is making it faster. It's actually making it slower. Then creating this is making it slower. 116 milliseconds. Earlier is 83. So that doesn't work. How about we do the other idea of I think J, right? And that's how we create complex numbers. Not 100% sure because I haven't done complex numbers for a while. Because I remember is you just put a J and it should work. I don't know, does it work? How do I do complex number? Python complex number. C math? Ugh, that's to do a complex? No, I don't think it's C math. Complex number. Yeah, but this is also creating, I don't know. So do you have to import something or it's just directly? I think you can just do it directly. So, oh boy, we do complex. I mean, none of these changes are actually I don't even need this. I can just do this. Yeah, none of these changes are fundamental difference. 115. I'm not sure. I think they are all not as good as the previous one because this, if we run it again, right? If we run again, we'll see it's actually fairly fast. Nope, not this one. Not this one, but solution 4. This one's fairly fast. $91, right? This one's fairly fast, but how'd you get it even down here? So I can shave off another half, more than half. Do we just use GCD? No, we cannot just use GCD because it's a different ratio, right? No, we just use, hold on, we want the ratio to be the same. No, it's this divided, so we just need to say this divided by this. Right, divided by this equals, yeah, there has to be GCD, and I'll have to divide. We can avoid one round of GCD, right? Is GCD AB equal to GCD BA? Yeah, I think they're the same. Don't understand why you do both times. They're the same. $96. Can try. I doubt it. Got on to 3,000, but it's basically the same, right? It's basically the same. All right, I will entertain this. This is a 3,000 version, but still, it's not fast enough. .3724 milliseconds and a 19.43 percentile. All right, I think I'm gonna stop here and then check the solutions tomorrow, because I don't know how much more. Unless we change how this is done, I don't know if it can even optimize it even more. Anyway, that'll be it for today. I will see you guys tomorrow. Adios.